Hey, how you doing? My kids are about to run through the video, so yes. Hi. Can't see me at all? And Dylan. Let's go. Ow, 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 ow. Well, Mom, let's give us the tablet if you want the tablet. Whoa. Can you see me? Hey, everybody, can you see me? Hello. AJ, can you see me, sir? I can see the computer screen because you were talking. Okay. Katie, can you see me? Yeah. Can you see me? Oh. I see all of us. Oh, okay. All right. Okay. All right. See me? Okay, I need you to go that way. Say hey, AJ. Hey, AJ. This is an AJ right here too.
Hey guys.
Hey, look, mommy got to do class real quick, and if mommy can, okay, say bye. Bye. Come on, let's go watch mommy on my phone. Yeah, I can go watch mommy on Dr. Ann's phone. Go watch mommy on Dr. Ann. Go, 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 go. Go. Don't touch Dr. Ann's keys. Come on. Okay, sorry about that. No daycare, so I have to make do. How are you guys doing? I miss not meeting with you guys. Y'all know that? All right. Can you guys see the PowerPoint?
Yes.
Okay. I am going to turn off my video. And can you guys see me? Can y'all still hear me? I'm just trying to make sure everything is working because I just finished one class. All my screens around. Okay, you guys. I wish we could meet under better circumstances, but you know, this is how things have to go right now. What I am going to do as far as everything, I'm going to try to keep everything as normal as possible. I have put up all of you guys' assignments for the rest of the semester. I don't know how things are going to go. Hopefully we will be back. I am not sure. But everything is up for you guys. The only thing that I have not put up for you guys is your template that you need to follow for your presentation. Everything else has been put in for you guys. Your tests are just going to be multiple choice online. You guys mute your mic for me if you can, because it's going to do some feedback. And so as far as exam, duck it in, mute your mic. As far as classes and everything, what we're gonna do is your test gonna be online. I'm gonna try to keep everything as normal as possible. I am recording these, so if you need to go back, you guys can see that. As far as we're gonna do our test. I moved it back a little bit until the second. My plan and what I'm gonna do is I'm gonna go ahead and do chapter 8 today. We're doing chapter 9 on Thursday because we want to have that test on the second. And I want to go ahead and get the other chapters out of the way. I want to do a review of the math. You guys still should have your math packets. And what I want to do is next week try to get chapter 8, 9, and 10 done so that we can review before the test because I really do want to go over some of the math. And I do have a board here at home, so I'll be able to write that stuff up on the board and everything for you guys, so that won't be a problem. So let's get started with chapter number 8. So chapter number 8 really deals with lipids and membranes. And so when we deal with lipids and membranes, we're going to deal with a lot of things. So we say, what are lipids? And lipids don't follow a single structure template or share a common set of functional groups. Lipids are defined mainly by the absence of functional groups. So of all the things that we see, lipids do not have functional groups. Now, with that being said, we're going to take a look. Now, lipids are mostly known as fatty acids, and with them being known as fatty acids, they are very long chain hydrocarbons, and these are some of the ones that are listed here. Oleate, oleic acid, all of those. These are some ones that are listed right here. And I know I have one of my friends that a lot of times in food chains, they use oleate or fatty acid. That's where they fry a lot of their foods in. A lot of the fast food chains use that. And I have a friend of mine that is allergic to it. So she really cannot eat out and eat anything fried out because she has allergic reaction to that. So fatty acids, they are long chains. So with that, you got saturated fatty acids, and then you got unsaturated fatty acid. Now, unsaturated fatty acid contains one or more double bonds, and so that's what it is. Now, they are common in biological systems. So, fatty acids are the simplest lipids that are out there. Now, there are other ones. Like yesterday, I ate salmon, and so salmon has omega-3s in it and everything. Now, fatty acids, they can be saturated with different types of hydrocarbons and all of that. So those are the main two. They can be saturated with fatty acids. Now, I was saying before, fatty acids can be unsaturated, or they can also be polysaturated as well. Now, when you talk about the double bonds with these, they are usually in the cis conformation. So when we talk about these fatty acids, they're usually in the cis conformation. Now, you got some free fatty acids that are relatively scarce systems. So so a lot of times we find that now the fat and oil in animals and plants, those are triglycerides or triglycerides. They have those group that are in there. Now, this chart right here really shows some of the common fatty acids that are out there. Stearic acid, lauric acid, like I said, acid is unsaturated fat. So it's all types of ones that are out there. Like I said, a lot of times they use these to actually cook with. Now, like I said, they are usually found as part of triglycerols. So you do find those or triglycerides. And so those are found out there. Now, you also have another set that are out there. They're called glycerol-phospholipids. So they got glycerol in the backbone, and then they got those fatty groups estified in positions 1 and 2. And so these are some of the ones that are right here. And they often have unique head groups. And so the lipids are usually named according to their head group. So that's what these are really named. Now, so some of them can be amphipathic, which means they have a hydrophobic tail attached to a polar or charged head group. So you got different types of those. Now, when you talk about phospholipids, they cleave to those phospholipids at specific sites. So as you can see here, you see D attaches there, C attaches there, A attaches one place, and A2 attaches another place. So they have specific sites that they like to cleave to. Now, there are some other ones that are out there. So you got different ones. So in the book, looking at these, you got your phospholipids, you got eukaryotic membranes that are also amphipathic lipids known as sphingolipids, and they are attached in different places. So the glycolipids are also known there as well. Now, with those, this one, the sphingosine is derived from palmitate and serine, and so you can see that whereas you got one part is from one, and then on the other side is derived from both of those. Now, with this one right here, your sphingomyelin has this head group that is on there as well. And so when you talk about lipids, you know, they are very heavy molecules, and they have all these different type of groups that are on there. Now, some of these, your sphingolipids, can also have monosaccharides as head groups as well. So with these lipids, you can have different types of. One of the things, why do we care about this? Now, lipids have a variety of psychological functions. Now, one of the things that I have heard in times past, especially from older people, saying that if you have extra weight on you, you're really smart. I don't know where that came from, but that's what they say. Sometimes what they say, you know, you got a bigger head, more knowledge, because you got more fat up there. My dad did say all types of crazy things. But more so than that, we know a lot of physiological functions. And so we're going to talk about that a little bit. Now, here they're saying the oligosaccharides can be head groups as well. So you guys see that on your screen. Some of the lipids are also derivatives of isochronism. So lipids can come Now, one of the ones that everybody be concerned about a lot. Now, cholesterol is an isoprene. So it's coming from isoprene as well. And cholesterol, you got good cholesterol, you got bad cholesterol. Um, and so you see it there, and cholesterol got only this one group. And then going on, you got ubiquinone is also an isoprenoid derivative as well. And so you can see that where you got the isoprene units right there in the middle of it. And so you got different ones. Now, with metabolic precursor or steroid hormones, such as estrogen. So it's a metabolic precursor. Um, so, um, so that's why we say. So it says in humans, the derivative of fatty acids are signaling molecules that can help regulate blood pressure, pain, and inflammation. Many plant lipids function as attractants for pollinators, or repellents for herbivores. So you can have that where these can be unique. And um, so the reason why you don't want high cholesterol is because that you have higher blood pressure in some cases. And you not only have that, you can also have pain, and you can also have inflammation. Now, when I said earlier that plant lipids function as attractants, and so I know a lot of people out there, especially myself, I know I'm praying that the virus don't come near me, but this pollen has got to go. Oh my God, it just getting to you. And so you got a plant lipid that functions as an attractant. So a lot of times you need that attractant because we need to pollinate the plants, and then pollinate. So this is just one of them that you see here on the screen. Now, in the book, one of the things that I wanted you to look at. Now, we have certain vitamins that are also lipids as well. So, vitamin A, E, and K. So that's what it is. So we got some of them that are listed right there. So retinol, vitamin A, vitamin D, um, vitamin K, they're listed there on page 221 in your book. And so we have vitamins, and I want you guys to ask you those questions on the test, that vitamins are also lipids. And so not all of them, but these particular ones. So make sure that you know that vitamins A, D, E, and K are also lipids. Now, when we go on to that, and here go one right here, uh, limonene gives citrus fruits their characteristic color. So that is one that you see right there. So I think I made lemonade on yesterday. So there's some other one. Capsaicin give chili peppers their hot taste. So there are a lot of different fatty acids that are out there, and these are just some of them. Now, in section 8.2, we're going to talk about the lipid bilayer and what it is. So the lipid bilayer is really defined as a two-dimensional way applicated molecules with chains associated with each other out of contact with one another, and repeatedly interact with an aqueous solvent. So the beauty of the lipid bilayer as a barrier for biological systems is that it contains this is a spontaneous reaction without the input of non-polar. So now that is due to the hydrophobic effect. Now, so right here, you see a picture of a lipid bilayer. So you see the heads and you see the tails, and that's what it is. The tails interact with each other. Now, some of the molecules in the lipids that I showed you earlier have large heads, hence that they are named for that. So here, this is what you see. You see a simulation of the lipid bilayer. Now, right here, you have this bilayer. So the carbon atoms that you see on there, they are gray. You see your lipid tails that are on there, and the lipid tails are yellow. Your ester oxygen atoms are red, and your phosphate groups are green, and your choline head groups are magenta. So you see that. Water molecules on each side of the bilayer here are shown as blue spheres. And so that's what you're seeing right there. Basically a simulation of the lipid bilayer. Now, what about the, what does that mean? Now, the bilayers, the lipid bilayers, they are fluid. They are fluid structures, and usually the reason why you see them like that, they really don't have any defined structure or geometry. So now, what are they? How big are they? Now, these are usually about 30 to 40 angstroms in size, and they have a hydrophobic core that is about 20 to 30 angstroms thick. So the hydrophobic core is really thick, and then it got that hydrophilic outside, and that's what it is. Now, what they're saying is when you come to the lipid bilayer, they are really hard to describe them. And that's because they're very dynamic in their assembly, and that's what you see in the simulation. These are complex structures. The head groups bob up and down, and the hydrocarbon pairs of the lipids, they're always in motion. That's why they're interacting with each other. And so the head groups, so at the center, the bilayer is a separate. So with it being fluid, bilayers can really change. They can bend. So they can really interact. So and they interact between two obvious components. So what are you seeing here? And what you see here is you got double bonds keeping the alpha change in the lipid. And so that's what you see. Now, why and how can you describe the fluidity of these? You got to determine it in terms of the so, and that's basically going from a crystalline state to a more fluid state. The metaphors don't refer to the conformational shift. No, it just refers to, okay, we're taking it from hard to making this very soft and more flexible. That's what we're looking at that. Now, when you look at those alkyl chains, they are packed together in van der Waals. And in the fluid phase, you got your methanol groups, and they can rotate freely. And so that's what they're saying. So right there, double bond keeps right there in the alkyl chain. And so what you do is you have to melt it in order for that double bond to break so that it can be less. So that's what they're telling us. That double bond introduces a key into the alkyl chain, so the unsaturated alkyl chain is less able to pack unable to pack against its neighbors. Now, what happens to that melting point? Now, when it comes to that melting point, it decreases as the degree of unsaturation increases. Now, what about the lipid bilayers? Now, you have these lipid bilayers. You can have diffusion through them. See here, the two bilayers seldom have identical compositions. Now, you can have some that have a so cells, and that's mostly a consequence of orientation of synthesizing enzyme in the distinct compositions of the inner and outer are preserved by the extremely slow rate in which most membrane lipids undergo what you see here on the screen, transverse diffusion. So basically what it does is it's very slow and very long flip flop. What happens is one leaflet to another. Now, if you look at this from a thermodynamic point of view, it's unfavorable since it will require passage of a solvent polar head through the hydrophobic interior of the bilayer. However, what happens is the cells do and can move certain lipids between leaflets with the assistance of the enzymes, and they're called translocases. Lipid molecules undergo lateral diffusion, and that's what you see at the bottom. That is movement within one leaflet. And now what happens is a lipid changes places with its neighbor as often as 10 to the 7 times per second. And so that's what happened. They change positions so much, and they can happen so rapidly. So you see here, so you got the difference between transverse diffusion and then lateral. Now, what about membrane proteins? Now, when you talk about membranes, and we touched on membranes just a little bit, biological membranes consist of proteins and lipids. So that's what it is. On average, a membrane is about 50% protein by weight, but its value varies widely depending on the source of the membrane. Some bacterial plasma membranes and organelle membranes are as much as 3/4 protein. So most of the time when we look at membranes and biological membranes, mostly made of protein, some fat, and so are lipids in there. By itself, a lipid membrane serves mainly as a barrier to diffusion of polar substances. So that's one of the functions. And all the additional function of the biological membrane depends on membrane proteins. Now, other things. Some other membranes, proteins, sense exterior conditions and communicate them to the cell interior. So not only the so we see that now here you got proteins associated with membranes in different ways. So you got membrane proteins known as integral or intrinsic membrane proteins. A portion of the structure is fully buried in the lipid bilayers. Now, so looking at this is basically a cross section of the integral protein there. Now you got your peripheral membrane protein, and then you got your lipid link protein. So um, so your peripheral or extrinsic membrane proteins, they are mostly loosely associated with membrane, their interaction with lipid head groups or membrane proteins. Except for their weak affiliation with the membrane, water-soluble proteins. Now, what can happen? All but a few integral membrane proteins completely span the lipid bilayer. So they are exposed to the hydrophobic interior as well as the aqueous environment on each side of the membrane. Now, what else can happen? So you got lipid link that is there as well. Now, what else can happen? You can have a helix that cross over the bilayer. Now, one way for the peptide chain to cross the lipid bilayer, it forms a helix. And so when it forms the helix with side chains, those side chains are hydrophobic. The hydrogen bonding tendencies of the functional groups of the background are satisfied through hydrogen bonding in the alpha helix. And so that's what you see there. And so here, that's what you see, a portion of the amino acid sequence from the protein bacterial ribosome. And then what you see is B, the three-dimensional structure of that sequence. Polar residues are purple and then so that's what you see. Purple and now, to span, now we're going to talk about this. To span a 30 amino acids. Also the spot by a sequence. Is highly hydrophobic. The amino acids that are in there are some that are listed there and everything. Now, many integral membrane proteins contain several membranes spanning alpha helixes bundled together. And so that's what happens with it. Now, that's what they're saying. The membrane proteins can span the bilayer. Now, this integral membrane consists of a bundle of membrane spanning alpha helixes. And so that's what they're showing here. The helixes are colored in rainbow order from blue N terminus to red, and that's the C terminus. The horizontal lines approximate the outer surfaces of the membrane. And so on the other side, you got your beta barrel, and then this is 8 strands of this E. coli. So this is an E. coli protein known as UMP-X, fully hydrogen bonded, where they span the width of the bilayer. Hydrophobic side chains, and they are in green. You see them there, they're in green. And then you got your aromatic residues that are in gold, located mostly near the lipid head groups. So that's what you see there. And the reason why they're showing this one, when you got your beta barrels, they and so when you got a polypeptide that's across the membrane, a beta strand, it will leave hydrogen bonding backbone groups unsatisfied. If you have several of them fully bonded, they can cross the membrane, and the energy of it will be favorable. And in order to maximize that, that's why they have to form that. Now, the other thing that we're going to look at right here is the second group of membrane proteins. They are lipid linked. And so they can be covalently linked in a lot of ways. Most of these proteins that can be linked, they are usually soluble in then what you do is you can anchor them in a lipid bilayer, and they're attached to a group. A few of the lipid-linked proteins also contain membranes spanning polypeptide segments. So that's what you are seeing. Anchors, they are shown in green. So at the top where the head is, those are blue, and then at the bottom, that's green. Other groups that are in there, if there's some in there, like prenylation, that methyl group is purple. And so you can have that. Now, here, the saccharide residues that are in there as well. So now, what size are these? Now, some of these can contain different things. And I just want to go back to that for a moment. You can have different ones. They can contain eukaryotes. They're prenylated. They contain 15 to 20 carbons. Isoprenylate groups. Okay, the C-terminus is also used carboxymethylated. Now, you can have different types. You can have lipid carbohydrate groups at the C-terminus. Those lipid surface of the cell, and you can find those essentially in base wraps. So you can find those. Now, the last section that we're going to go over today is the fluid model. Now, why do we care about this? So, what is so important about this model? So, biological membranes consist of both the proteins and the lipids. So, some of them, when they are mixed like that, it's not entirely random. Certain lipids appear to be associated with specifically certain proteins. So there are certain ones they like each other, possibly to stabilize the protein structure or to modulate the function. So you can see that. So a given protein has a characteristic orientation. That is, the faces on one side of the membrane or on the other. After it has been assumed in nature, it does not undergo flip-flop because this will require passage of large polypeptide regions through the hydrophobic bilayer. So what they're saying is the lateral movement is still possible. So when that is still possible, you can have a lipid-linked protein that can diffuse within the plane of the bilayer. It's going to be a little bit slower, but it can do that. Now, this is a key feature of what we call the fluid mosaic model. And so this was discovered by S. Jonathan Singer and Gart Nicholson. So according to their model, the membrane proteins are like icebergs floating in a lipid sea. So that's what they're saying is you got that space up there, you got cytosol, and that's what they're doing. A sea of lipids, and it can move laterally, but it cannot flip-flop. They can't flip-flop at all. So they can just move around. I'm trying to see, is there anything else? And it said many membrane proteins do not diffuse as freely as they first thought. Their movements are hindered to some degree according to whether they interact with other membrane proteins or with cytoskeletal elements that just lie beneath the membrane. That is, a given membrane protein may be virtually immobile if it's firmly attached to the cytoskeleton, mobile with a small area. So that's it for chapter number 8. Just a couple of things that I want to make sure that you guys know, just to make sure that you guys are going over that. Um, Lipids are largely hydrophobic molecules. The fatty acids can be esterified to form triglycerols. Uh, the glycerophospholipids contain two fatty acids attached to a glycerol backbone. Uh, there's a phosphate derivative, so that is important. Lipid bilayers, they are dynamic structures. Their fluidity depends on the fatty acids. Shorter and less saturated groups are more fluid. Cholesterol that maintains membrane fluidity over a range of temperatures. Another thing, membrane lipids can freely diffuse laterally but undergo transverse diffusion very slowly. Membranes may contain crystalline rafts composed of cholesterol and sphingolipids. Now, integral membrane protein spans the lipid bilayer as one or a bundle of alpha helices or as a beta barrel. Some membrane proteins are anchored in the bilayer by covalently linked lipid group. And then lastly, membrane proteins that fuse within the plane of the bilayer. The mobility of the proteins may be limited by their interaction with cytoskeletal proteins. Membrane glycolipids and glycoprotein face the cell exterior. Um, that is all that I have for today. We will get to chapter 9 on next time. What I want to do is go ahead and finish up chapter 9 and 10 because especially in chapter 7 and a little bit of chapter 9 have some math. And then while I want to finish those up, I do want to get through because technically we're supposed to have our test toward the end of this month. I did move it back a few days to the 2nd. So I do want to go ahead and get finished with that. If you guys have any questions or concerns, please let me know. Like I said, I'm going to try to keep this as normal as possible and everything so we can all get through this a little bit easier. I know with you guys, most of you guys being seniors, this is kind of like what in the world is going on type of thing. So I'm gonna close out the meeting. I will try to have office hours at night when the boys are down between like 8 and probably, well, I'll say about 9 and about 10:30. I have to make sure they are asleep first and good and sleep before they work. So I'll try to have office hours during it. That one's going to have a different meeting number, and I'm going to send it out to all my friends. So if you got any questions or anything like that, and what we're going to do is I'm going to try to do 9 and 10 rather quickly this week so that we can be ready and review for our test on, and I guess that's going to be Thursday. I'm only going to come on for a few minutes. It's going to mostly be multiple choice. Most of the tests are going to be in 2 parts when you do the multiple choice part, and then you're going to have a few questions that you will have to just write out the answers to that I will have to grade. Those parts will be timed. So you will have a limit when you sit down and start it, you have to go ahead and finish it. That's one of the things that they gave to us, that the tests do have to be timed. Now, the time for those exams are going to be basically the time that you are like in in the classroom. The tests are going to be on that particular day. So you have any time that particular day, if it's on the second, to take the exam. I'm only going to come on to just basically tell you about the exam, what the exam is, see if anybody got any questions, and then you can take the exam anytime that particular day. So that's what I'm going to do. So the tests have been moved back. Is going to be on the second, and then we're going to move on. And like I said, we're going to keep going. Now, if we do have time at the end, and I know some people got questions about what about this final exam. I have discussed it with Dr. Craig. Dr. Craig said that he's going to look at the test and he's going to give me topics that are on the exam, because I'm not going to look at the exam. They are locked up in Dr. Craig's office. What he's going to do is look at it and give me the topics. And what I'm going to do is form questions or look at questions that we have had based on those topics. That is what's going to be put on your final exam. So that's how we're going to do it. If you give me those topics, I would give those topics to you in a study guide to tell you these are the topics that's going to be on the test. It won't necessarily be questions. It'll be the topics that you need to look at. So once you give me the topics, I'm going to give you the topics, and basically I'm going to form the questions based on that, because that's what we're going to have to do if we're not back in school. Now, if we're back in school, we'll have the regular exams. But if we're not, that's the contingency plan. So I wanted to give you guys a heads up on that, just in case. So like I said, I don't know. I'm praying that we be back. But if we don't, that's the contingency plan that is in place. Let me know if you got any questions. Send me an email. It would be seeing you guys and talking with you guys. I will talk to you guys later. Have a good